The Franco-Prussian War of 1870–1871 changed France's destiny forever. The heirs of Napoleon suffered a crushing defeat. After the disaster at Sedan, the Prussian army opened a direct path to Paris. The capital found itself in a steel grip, surrounded by the enemy's impenetrable trenches. The Prussian generals believed they had completely cut the city off from the outside world. But the Parisians came up with a brilliant way to break the blockade. They turned to a technology invented by their countrymen a century earlier: hot air balloons. These gas or fire-filled vessels allowed nearly 2,000 people and tons of vital mail to be carried over enemy lines. During the siege, dozens of balloons rose above German positions, drawing both amazement and irritation from the enemy. This daring spectacle helped Paris maintain contact with the outside world. But more importantly, it left a deep impression on one Prussian officer. Cavalry Major Count Ferdinand von Zeppelin saw in those flights the spark of a greater dream. Zeppelin lived in a time when technology was just beginning to reshape the concepts of transport and communication. Balloons, as impressive as they seemed, had serious limitations. But in Zeppelin's mind, they ignited a bold idea: the dream of a steerable airship, a vessel that could travel where the pilot wished, not where the wind commanded. It was a dream born in an age when horses still ruled the roads, and aviation was a fantasy for eccentrics. The war revealed that the sky could be a new path, and Zeppelin recognized its potential. The siege of Paris became his point of departure. He watched as the French used balloons to transport letters and people, and he understood this was only the beginning. Balloons could ascend, but they were helpless in the face of the wind, unable to chart a precise course. That problem became Zeppelin's challenge. He began imagining a craft that could navigate the skies between European cities. But to achieve that, he needed to solve the core problem: control. Zeppelin had no background in engineering. His military career and noble status gave him confidence, but also put distance between him and the technical world. Yet the very nature of that era, where traditional warfare clashed with emerging technologies, pushed him to reflect on practical, steerable aerial transport. To most people at the time, the idea of controlled flight was pure fantasy. Balloons were seen as marvels or amusements, not reliable tools of transit. But for Zeppelin, they became symbols of possibility. He saw how the desperate French still managed to organize aerial communication. And that convinced him the future belonged to those who could conquer the skies. His dream, born in war, looked toward peace, a craft that would travel by plan, carrying people and cargo between cities. However fantastic it seemed, that idea became his compass. The Franco-Prussian War exposed the weaknesses of conventional armies and showed how technology could alter the course of history. For Paris, the balloons were salvation. For Zeppelin, they marked the beginning of a long journey. He lacked the technical knowledge, but he had vision and the determination that would one day change the way we think about air travel. As those balloons drifted over the trenches, Zeppelin was already imagining their evolution. Instead of swaying with the wind, they would become true airships. That chapter of his life was his comfort zone, a world where, as a soldier, he understood the importance of logistics and communication, and the deep desire to transform them. The balloons that had so deeply impressed Ferdinand von Zeppelin during the Franco-Prussian War suffered from a fatal flaw. They were entirely uncontrollable. Caught by air currents, they drifted wherever the wind took them, making them unreliable for deliberate directional transport. A striking example came during the siege of Paris, when one such balloon, launched in hope, ended up 5 days later in a forgotten Norwegian village, more than 1,500 kilometers away. For the two passengers, stranded so far from their intended destination, it was a clear sign of the technology's limits. Zeppelin realized that a true breakthrough would require a craft that could move independently of the weather, something that could be steered. That need became the center of his obsession. He saw in airships the potential to connect cities across Europe, but the challenge was immense. Without control, there was no future for aerial travel. The age of technical progress had just begun to accelerate. The invention of the internal combustion engine opened up new possibilities across all forms of transport, from cars to ships. Zeppelin understood that these engines could hold the key to building a steerable airship. But his ambition clashed with reality. Many saw the idea of a navigable dirigible as absurd. Still, he studied what other countries were doing, met with engineers, and sought support from powerful figures. Often his efforts were met with ridicule. When Zeppelin shared his plans, people treated them like the fantasies of an old cavalryman. His early sketches were especially mocked. He imagined an airship made of multiple balloons tied together with a shared gondola suspended below. The design lacked the rigidity needed for stability and created massive air resistance. Even with an engine and a propeller, it was unlikely to travel in any set direction. Engineers could see these flaws immediately, but Zeppelin, without formal technical training, had no way of knowing. Still, he refused to give up. He knew he lacked knowledge, so he began searching for those who could fill that gap. What Zeppelin did have was organizational skill and an ability to bring the right people together. His stubbornness and belief in the steerable airship helped him move forward, even when most thought his project was doomed. Society wasn't ready for the idea of air travel on a mass scale. Aviation was still a distant dream. Balloons were seen as curiosities or military novelties, not practical machines. This stage of Zeppelin's life was full of obstacles. He found himself confronting both technical and social barriers. The need for a steerable airship became his driving force, but the road ahead was steep. He understood that success required not just building a working machine, but convincing the world it was worth building. His persistence in the face of mockery and doubt laid the foundation for what would come. This was a time of struggle against deep-rooted public skepticism, a time when most still thought airships were impossible. Despite the mockery and disbelief, Ferdinand von Zeppelin refused to give up on his dream of a steerable airship. Aware of his lack of technical knowledge and resources, the Count made it a priority to enlist skilled engineers. Among those who joined him, two stood out: Hugo Eckener and Theodor Kober, men who would become the backbone of turning his lofty ambitions into reality. Zeppelin also studied foreign developments closely, constantly looking for inspiration to move closer to his goal. A turning point came on November 3, 1897, when Zeppelin attended a demonstration of a rigid airship designed by a little-known Austrian engineer named David Schwartz. The design was revolutionary for its time. It consisted of a cigar-shaped metal frame made of steel tubes and covered in fabric. Inside, hydrogen-filled gas cells provided lift. Unlike soft balloons, this rigid structure maintained its shape even in strong winds, a major advantage. But it also had a fatal flaw: excessive weight. The airship barely lifted off the ground, carrying only a single pilot. The test flight ended in a crash, typical of many daring experiments in the early 20th century. Nonetheless, the German military showed interest and sent Schwartz a telegram offering collaboration. Tragically, overwhelmed by the attention, Schwartz died of a heart attack before any deal could be made. Zeppelin saw something in Schwartz's design that his own concepts lacked. He acquired the late engineer's notes and calculations from his widow, and these would later form the foundation of his future work. The idea of a rigid frame opened an entirely new engineering world for Zeppelin, one where structural strength, aerodynamics, and weight had to be carefully calculated. For a military man with no engineering background, it was a leap into the unknown. His earlier designs, balloons strung together with a hanging gondola, proved unworkable due to their lack of rigidity and excessive air resistance. Schwartz's prototype showed the way forward, a solid framework capable of withstanding pressure and maintaining form in flight. This period was a true trial for Zeppelin. He faced the reality that enthusiasm and military experience alone weren't enough to build a complex technical machine. He had to adapt, learn to trust engineers, and work within a discipline he barely understood. His persistence and ability to attract the right people helped him overcome the first hurdles, but the path ahead remained long and difficult. Schwartz's demonstration became both a source of inspiration and a hard lesson. Creating an airship would require not just vision, but also learning from every failure. This chapter laid the groundwork for future progress, but it also revealed just how much work lay ahead before the first real airship could take to the skies. Armed with David Schwartz's ideas and the support of skilled engineers, Ferdinand von Zeppelin began work on his first airship, the LZ-1. The project was nothing short of monumental. At the end of the 19th century, building a steerable flying vessel still bordered on science fiction. But a year after encountering Schwartz's design, the LZ-1 was complete. It emerged from a floating hangar on Lake Constance, and even today, its specifications are impressive. The LZ-1 stretched 128 meters in length, as long as a modern 5-story building. Inside, it housed 17 hydrogen-filled compartments, ballast tanks, and gasoline reservoirs for its two 14-horsepower engines. The crew operated the ship from 2 aluminum gondolas connected by a metal walkway. The LZ-1's maiden flight lasted just 20 minutes, and it was both a triumph and a disappointment. The airship managed to lift off and travel a short distance, an achievement in an era when cars were still a rarity. Yet serious flaws quickly became evident. The steering system was nearly useless. The ship barely responded to pilot commands. The engines, though innovative, lacked the power to resist even moderate winds. Worse, the engineers had miscalculated the strength of the frame. During the flight, the structure deformed, making the airship unusable without a complete rebuild. These failures hit Zeppelin and his team hard. After 3 test flights, it became clear that the LZ-1 had fallen short of expectations. Initial investors and military backers lost interest. The ship that was supposed to herald a new era of flight was dismantled and sold for scrap. For Zeppelin, it was a crushing blow. He had poured time, money, and his personal reputation into the project. But this phase marked an essential moment of adaptation. He realized that building a functional airship required more than passion. It demanded precise engineering, strong materials, and more powerful engines. Despite its failure, the LZ-1 was an important step forward. It validated the idea of a rigid frame, borrowed from Schwartz, but also highlighted the need for refinement. Zeppelin and his team gained invaluable experience, learning more about aerodynamics, weight distribution, and working with hydrogen. The project also reinforced the importance of collaborating with experts who could compensate for Zeppelin's own lack of technical training. While the LZ-1 never achieved commercial success, it proved that a steerable airship was possible and laid the foundation for what came next. Undeterred by skepticism or financial obstacles, Zeppelin began seeking new ways to continue the work. After the failure of the LZ-1, Ferdinand von Zeppelin stood on the brink of total collapse. But his dream caught an unexpected lifeline. King Wilhelm II of Württemberg, an avid supporter of air travel, offered Zeppelin financial backing. This funding allowed him to continue his work. However, the next prototype, the LZ-2, was destroyed by a storm before it could even be properly tested. The disaster forced Zeppelin to pawn off the last of his family's valuables to finance one more airship, the LZ-3. This would prove to be the breakthrough. Filled with 12,000 cubic meters of hydrogen and equipped with 2 90-horsepower Daimler engines, the LZ-3 stayed aloft for an impressive 8 hours during its trials, cruising at over 40 km/h on average. The success drew immediate public and military attention. Newspapers around the world praised the German marvel of engineering, and the Army purchased the LZ-3 and commissioned 2 improved versions. The military saw these airships as promising tools for long-range reconnaissance, equipping them with powerful radio transmitters. However, this electrical equipment posed its own risks. It often produced sparks, a dangerous flaw when using hydrogen, an extremely flammable gas. To reduce the threat, radio operators were stationed inside pressurized compartments with forced air, a partial solution at best. Hydrogen remained the Achilles heel of the entire design. Hydrogen's low cost and availability made it indispensable. But any mistake could lead to catastrophe. This danger was painfully demonstrated in the LZ-4 disaster. While docked during a layover, the ship was caught in a gust of wind, struck a tree, and erupted in flames within seconds. Fortunately, no one was hurt. But the incident exposed the vulnerability of airships using hydrogen. And yet, the tragedy had an unexpected effect. Instead of abandoning Zeppelin, the German public rallied behind him. In a matter of weeks, he received 8 million marks in voluntary donations, a turning point that allowed him to restart and expand the project. Zeppelin had finally reached his goal. His airships were now recognized as legitimate, functioning forms of transportation. But the price was steep: financial peril, personal sacrifice, and relentless technical obstacles. The LZ-3 became a symbol of his dream made real. It proved that controllable airships could travel long distances and perform meaningful tasks. Still, the dangers of hydrogen and structural flaws continued to cast a shadow. This stage marked the moment when Zeppelin's vision began to bear fruit, but also reminded him and the world how fragile those achievements remained. Military recognition and public support enabled the next steps, but each flight remained a delicate balancing act. The 8 million marks in public donations following the LZ-4 catastrophe became the defining moment of Ferdinand von Zeppelin's career. With those funds, he transformed his modest workshop in a rented hangar into a sprawling industrial enterprise. Within just a few years, under his leadership, factories were established to produce hydrogen, process metals, and duralumin, weave specialized fabrics, build storage facilities, and construct custom docking stations for airships. It was the beginning of a true golden age. Zeppelin's airships expanded in scope, serving both military and civilian purposes. By 1913, specially designed passenger airships had transported over 36,000 people, a staggering number for an era still in aviation's infancy. Success returned Zeppelin to a world of respect and stability. His ideas no longer met with ridicule, but admiration. The airship became a symbol of progress, and its capacity to carry large numbers of people over vast distances captured the public imagination. Zeppelin's company built an entire infrastructure to support the airship network: hangars, refueling stations, maintenance workshops. Passenger travel opened a new chapter, showing the airship's viability not only for military use but as a civilian mode of transport. This period revealed Zeppelin's organizational brilliance. Though he lacked deep technical knowledge, he assembled a team of experts and orchestrated a highly complex manufacturing process. His company became a model for how one man's vision could mobilize many and yield massive results. Zeppelin airships flew between cities across Europe, and each journey was a public event reported in the press. For thousands of people, these airships were their first experience of flight, turning them into icons of a new era. With commercial success came new challenges. Hydrogen remained dangerous, and airship design still required constant improvement. Yet the public's support and financial stability allowed Zeppelin to focus on refining the technology. His enterprise became a hub of innovation in aviation. For years to come, the airship would be synonymous with German engineering and technological progress. This period marked the culmination of the Count's lifelong mission, a time when his dream of steerable airships became a shared reality for thousands. Having achieved commercial success and public recognition, Ferdinand von Zeppelin's team turned its focus to improving airship design, aiming to make their machines more efficient and safer. One of the most pressing challenges was the quality of materials used for the gas cells. Initially, they were made from rubberized fabric, which had high gas permeability and allowed hydrogen to escape quickly. Engineers found a solution in goldbeater's skin, a specialized cotton fabric coated with multiple layers made from the digestive lining of animals. This new material held gas far more effectively, enabling airships to remain aloft longer and undertake extended flights. Another major area of development was aerodynamics and flight control. For a long time, Zeppelin's engineers struggled to agree on the ideal shape and configuration of control surfaces. A breakthrough came from a competitor, shipbuilder Johann Schutte, who mathematically demonstrated the advantages of cruciform tail fins placed at the rear of the airship's elongated hull. This cross-shaped tail greatly improved stability and maneuverability, especially in windy conditions. Schutte successfully implemented the design in his own airship, and although Zeppelin's team never officially acknowledged borrowing the idea, all subsequent Zeppelin models adopted the cruciform tail. It was a clear example of how competition could drive progress in aviation. These innovations demonstrated how Zeppelin's team had mastered their craft. They tackled complex technical challenges once thought unsolvable. Improved materials and control systems made airships more reliable and practical. At the same time, these advances highlighted that Zeppelin's success wasn't just about his vision, it was the work of brilliant engineers who brought that vision to life and refined it. Each new airship was better than the last, pushing the technology closer to its peak. This period also underscored the importance of learning from rivals. While Zeppelin remained the figurehead of the project, his team actively adapted and improved upon ideas from others. The cruciform tail and advanced gas cell materials became decisive innovations that made airships more viable for both passenger transport and military use. This chapter cemented Zeppelin's reputation as a leader in aviation, and his airships became icons of engineering mastery in the early 20th century. Ferdinand von Zeppelin passed away in 1917, but his legacy forever changed the world's view of air transportation. One of the greatest milestones came with the Graf Zeppelin, an airship named in his honor. Built in post-war Germany through public donations, this 250-meter giant went down in history as the most successful airship of all time. Over a decade of accident-free service, it carried more than 13,000 passengers and flew over 1 million miles. Its routes spanned 50 countries, including a round-the-world journey and a legendary flight over the North Pole. The Graf Zeppelin embodied the full engineering triumph of the airship era, showcasing what was possible just as heavier-than-air aviation was taking its first steps. Its success highlighted Zeppelin's exceptional organizational talent. Though his background was military rather than technical, he managed to unite engineers, industrialists, and the public around a shared vision. His persistence, through failures, financial hardship, and widespread skepticism, proved the power of unwavering belief in an idea. But Zeppelin's legacy also had a darker side. The Hindenburg disaster and the outbreak of World War II brought the age of the airship to a sudden halt. Hydrogen, long the Achilles heel of these vessels, proved catastrophically dangerous. The tragedies that followed served as painful reminders of its volatility. And yet, Zeppelin's ideas are finding new life in the 21st century. Modern technology now makes it possible to consider airships as economical platforms for communications, surveillance, and environmental monitoring. Some projects even propose equipping them with electric motors powered by solar panels. These aircraft could carry drones and ride stable air currents in the upper atmosphere for long-duration missions, particularly in regions with weak air defenses. Though ambitious, these concepts are rooted in the same principles Zeppelin championed a century ago, using lighter-than-air craft to solve real-world problems. His true legacy lies in that spirit of innovation. He showed that even without formal expertise, great achievements are possible with belief in a vision and the ability to unite the right people. Zeppelin's airships reshaped the way we think about transportation and opened the skies to the public. Today, as scientists and military strategists once again explore the potential of airships, the name Zeppelin endures, a symbol of the pioneering spirit that transcends time and technology.